Alright guys, this is section 2.6. Our goal here in this section is to be able to fit lines to data in scatter plots and find best fitting lines. Some vocab: a scatter plot is just a graph of a set of data pairs, x, y. So we have a whole bunch of points, and a scatter plot is just basically all those points graphed on a coordinate grid. A positive correlation is when data is happening where y increases as x increases. A negative correlation is where y decreases as x increases. And then no correlation is when x and y values seem to have no pattern at all. So a couple examples here. See how we have, in this first picture, we have all these dots going down, so as x increases, so here's our x-axis, all of our y values are decreasing. So we say that this is a negative correlation. Think of it as a negative slope, if you will. The next one, as x increases, y is also increasing. So this one is a positive correlation. Okay, and then this last one, kind of all over the place as x increases and y increases. It's kind of all over the place since the dots are kind of all spread out and not really following any sort of pattern. We say that this is a no correlation. Okay, it follows no really pattern at all. Next, what we have is what we call a correlation coefficient. A correlation coefficient is denoted by R. It's a number from -1 to 1 that measures how well a line fits a set of data pairs, x, y. So it's basically seeing how well these points on the graph line up to make a line or not, basically. Okay, so if R, or a correlation coefficient, is near 1, so the positive one, the points lie close to a line with a positive slope or positive correlation. But if they fall near, or if that correlation coefficient falls towards a -1, the closer it is to making a negative slope. Okay? If it's near 0, the points do not lie close to any line. Okay? It doesn't really have a slope at all. So we can have anything between -1 and 1. That's it. We can't have any less than -1 or any more than 1. Okay? We could have exactly 0. We could have between 0 and -1, so like -0.5. Or it's kind of like following a negative shape or slope. We could also have a half, which is between 0 and 1. Okay, where it's kind of following a more positive slope. So for example, see if these have a correlation coefficient closest to -1, -0.5, 0, +0.5, or +1. So with this first one, as x increases, it looks like y is steadily increasing. But notice how they're not quite close together to make a perfect straight line. So we know it's not going to be exactly +1, but we do know it's going to be positive since it's going up from left to right. Okay, so I would give this about a 0.5. Okay, they're kind of close together, but kind of not, but they're still going up positively, so I do know it's positive. In the second one, notice how they're closer together than the first one, so we do know it's going to be more towards 1 of some sort. But see how as x increases, y is decreasing. So we know it's going to be negative. And since the dots are more closer together to form in a line, okay, this is going to be more towards a -1. Okay. Excuse me. So a best fitting line is the line that lies as close as possible to all the data points. Okay, so here I have this scatter plot of points And what I'm going to do is try to make a line out of it that fits as close as possible to the data. So if I try to approximate a best fitting line or try to draw one, first thing I'm going to do is make sure I have my scatter plot drawn on a grid or on a coordinate graph. Okay. Then I'm going to sketch the line that appears to follow the trend, so either positively or negatively. And there should be just as many points above the line as there are below my line. Okay, so that's important to find or to do when you try to make a best fitting line. Step 3 says, okay, choose 2 points on the line and then estimate the coordinates or find their slope. Okay, and then step 4 says write an equation using the coordinates chosen. So we did that back in section 2. Okay, you find the slope between those 2 points and then use one of the points to try to make an equation and that slope, okay, to find the equation of that best fitting line. So what we're going to do now is try to do an example of that. And it's not going to be perfectly perfect, okay? You might have a different equation in the end, okay, as somebody next to you, okay? It's not going to be perfect. There is going to be room for human error, okay? So this first example here, it says the table shows the number of Y in thousands of alternative fueled vehicles in use in the United States X years after 1997. It says approximate the best fitting line for the data. So step 1 told me, okay, I first need to graph my scatter plot, okay, or my points of data. So what I'm going to do, well, I don't have any scale yet on my axes. So I need to first make my axes. Okay. So when I do that, here's my x value. And how I'm going to do this is I'm going to go by 100s on my y-axis. Or not by 100s, by 50, sorry. So here I'm going to start at 0. I'm going to have a major break in my graph. That's what the little squiggly is there for. And I'm going to start at 100. Okay. And then I'm going to go 150, 200, 250, 300, 350, 400, 450, 500, and 550. Okay, and how I chose to go by 50s is by looking at my y's, okay, what values I have, okay, because they go from 280 all the way to 400 or 548. Okay, so I knew I needed to go some pretty big steps in my y's. And then down below for my x-axis, okay, I'm going just by 0 all the way up to 6. So what I'm going to do is start at 0. I'm going to make this 1, 2, 3, 4, 5, and 6. Okay. So, X represented X years after 97. Okay. And then this side was for vehicles. So, number of in vehicles. Okay. And that's in the thousands. So now I just graph these. So 0 and 280. It's not going to be quite perfect, I promise. And 1, 295. 2, 322. 3, 395. 4, 425. 5, 471. And 6, 548. All right, so here's our scatter plot, okay? We can already tell it's going positively, okay, from left to right. It's got like a positive slope. So now it says, okay, now I need to try to draw a best fitting line. And I promise you, it's definitely not going to be the most accurate there is. Okay, so what I'm going to do is try to sketch it out. And remember, when you do this, you need to make sure that you have as equally many points above your line as there are below it. Okay, so if I try to roughly sketch it, okay, kind of looks like that. Okay, so now I'm going to pick 2 points on my graph. Okay, so that one, that red one. There we go. Okay, so now I'm just going to pick any 2 random points on my graph. So say, or on my line, that is, sorry, not on my graph. Make sure it's on your line. So I'm going to pick this one right here. That one was 6, 548. And maybe this one right here. That one was 1, and according to right here on the graph, that is at 275. Okay, so here are 2 points. Notice that they are not exactly the points that might have been in my table, nor, or maybe they could be, right? Because see how I use 6 and 548, that's one of my points. Okay, so it could be true that you could use one of them, or you could use one that looks exactly like it's on your line. So notice that I'm using 1, 275 because it looks like it's where it's crossing on my best fitting line, but notice that really in my table I used 295 as the Y value. So they may or may not be exactly what you used in your table. Okay, that's good because we're trying to approximate, okay, get the best fitting line, not exact, okay? So this is why somebody next to you might not be having, or might not have the same points as you that you're using, okay? And that's okay. All right, so first, I need to find my slope. And remember from section 2, slope formula. All right, so if I label these, x1, y1, x2, y2, 548 is first for y2, minus y1, which is 275. And then x2 is 6, subtract out 1, which is your x1. Well, 548 minus 275 is 273 over 6 minus 1 is 5. So if you divide these, that is roughly 54.6 as your slope. Okay. So now I'm trying to make an equation. So I'm still needing to use my slope, use one of my points in either slope-intercept form or point-slope form to try to make an equation. And again, you can pick whichever point you want to use, okay, from the one that you made the slope out of. Okay, so I'm just going to use the first one. And to make it simpler, I'm just going to use point-slope form. Again, you can use slope-intercept form if you want to. So here's point-slope form. Your y1 is 275. We calculated the slope, which is 54.6. And x1 was 1. So distribute 54.6 x minus 54.6. Then I'm adding 275. So negative 54.6 plus 275 is going to be 220.4. So this is our equation for this blue line in our graph that best fits our data of our scatter point, or scatter plot, excuse me. Okay, so we did this all by hand. Okay, so in the next example it says, okay, use that equation of the line of fit from example 2 to predict the number of alternative fueled vehicles in use in the United States in 2010. So we're still using that equation of the line we had made. And for X, we're filling in the numbers, or the number of years that passed, okay, from 2010 from 1997. Because remember, X represented the years after 97. Okay, so the years passed up between 2010 and 1997 is 13 years. So we're filling 13 in for X. So if we evaluate that, that gives us 930.2, but that's just not 930.2 vehicles. Was in the thousands. So 1,000 vehicles. Okay. So again, we did that all by hand, but many graphing calculators have a linear regression feature into them. Okay, so they're built into it, and we can use that to find the best fitting line for our data. Okay, so if we want to make a scatter plot in our calculator, this is some things we're going to do, okay, to help get there. And it is a lot of steps, so make sure we go carefully one by one to get it in our calculator the right way. Okay, so the first thing we're going to do is enter the data values into your lists. Okay, so how to get to your list is if you hit the stat button, okay, and then hit edit. So make sure it's in edit and hit enter. Then you'll pull up a menu that says L1 and L2. Okay, L1 is the explanatory variable. That is your X values. Okay, and the response variable is your L2, which is your Y. It's kind of like input, output. Input is your X value, output is your Y value. So stat button, edit, enter. So you're filling in all your X values in L1, enter all the L2 values or the Y values into L2. Okay, and if you can't somehow get out of there, hit second quit, okay, or second mode, okay, which is the same thing as mode button, which is right beside of it. Second mode or second quit. Okay, so now we have the lists in there, X and Y. Then we're going to define a scatter plot in the statistics plot menu. So if you hit then second, so the second blue button, and then hit Y equals, okay, second Y equals, we're at stat plots. Okay, so stat plot. So we're at this step right here in step 2. Make sure that it is at stat plot, and then you hit enter, and it'll bring up this menu right here, okay, that I drew the arrow to. Make sure that plot 1 is highlighted and that it's highlighted on. Okay, plot 1 is highlighted and on is highlighted. Then this little picture that says type, make sure it has the dots one, because that's scatter plot. Make sure it says list 1 and list 2, so the X's and Y's. And that this little marker is highlighted to make the points on the scatter plot. And it'll also say color at the bottom You can choose to make it a color, okay, whatever color you want. I have mine always set in blue. Again, you can have whatever you want though. So now you could just hit clear after you get those settings in. And now what we're going to do is hit zoom stat. So if you hit the white button up top, zoom, and then hit number 9, okay, it'll give you your scatter plot, which will look like the second picture here. It'll have your data already graphed for you. It'll have the axes already graphed for you, okay? If you cannot see your dots or scatter plot, you might have to fix the window. If that's the case and you still can't see your dots, let me know and I can help you out there, okay? So notice that there are no scales on the axes and that the axes are not labeled. If you copy a scatter plot from your calculator onto your paper, make sure you scale and label your axes, okay? Depending on what kind of data you're dealing with. So, still finding that linear least square regression line, okay? So your calculator can be used to find the linear least squared regression line, or that line of best fit, okay? I would go through the steps with you if I were able to pull up the calculator, but sadly I'm not. So I'm just going to go through these steps, and if you still can't figure it out on your graphing calculator, let me know and I can help you through that in class. Okay, so first what you're going to do is enter the data into list 1 and list 2, like I just explained before. You hit the stat and then edit, then enter to enter in your L1 or your X values, and then L2 your Y values. Then you're going to make sure that in mode, so if you hit the mode button and go all the way down to stat diagnostics, that it is set to on. So you're going to have to put it on probably yourself. Okay. Then if you hit clear, it'll get you out of there. Now what we're going to do is hit stat, the stat button. So it's 2 over from the green alpha button. And you're going to hit or go over to the right to calc. And then you're going to hit number 4, which is linear regression AX plus B. Okay. Then it's going to make sure it says L1 for X list and Y list is L2. It should say that. Go down to store regular EQ and hit the vars button. So it's right next to clear. Okay, so the variables or vars button. Then you're going to hit over or go over to Y vars or Y variables and hit enter on function and enter on Y1. Okay. Then hit enter, and if you hit calculate, it'll calculate the AX plus B linear equation for you. Okay. A is like your slope, and then B is the y-intercept. And it also, if you see, it will calculate your correlation coefficient R. Okay, or how well that scatter plot data fits a linear regression best fitting line. Okay, either positively or negatively. So if you go to the graph or hit graph button, it will show you the line, the best fitting line, and the scatter plot at the same time. Okay, and again, if you still can't find any of that stuff or it's not working for you, let me know in class so I can help you out. So in example 4, if you go through all those steps, we're using that linear regression feature on the graphing calculator to find the equation of the best fitting line for the data in example 2. So here's that data again from that table. So if we were to go through and do all that data again, okay, when you hit calculate in the very last step, and again, if you can't get that far, let me know, you should get 44.96x plus 255.96. Notice how the one we did by hand, which was, so we did the by hand one, we got y equals 54.6x plus 220.4. Okay, that was the by hand. This one was the calculator. Okay, notice they're not the same. So there's room for error in here. So you might not have gotten the same by hand as somebody next to you, but the calculator should give you the exact equation of that best fitting line, and your neighbor should have that exact same answer from the calculator. Okay,